Hello, Chemistry 20s. Our lesson today is going to be on matter classification. We started looking at this back in grade 8, all the way through to Science 10. So our lesson today is going to go rather quickly as we review. Matter is classified as anything that has mass and takes up space. So people always ask, okay, well then, what is something that would be classified not as matter? So something that wouldn't be considered matter would be something like a daydream. You can't weigh a daydream. So when you read like a comic and there's like the thought bubbles, that's not actually space. There's nothing there. It doesn't have a mass. Now, something like air, it does have a mass. It might not weigh a lot, but if I filled up a balloon with air and I filled up a balloon with helium, we certainly know which one is heavier. One does have more mass than the other one. They do take up space. Something like a dream or a nightmare, those things would not be classified as matter. Now, in previous studies, you knew that matter broke up into two categories. It's either a pure substance or it is a mixture. And we learned a definition on those. And I'm going to be very careful with the language we choose today. So, for a pure substance is a substance that contains only one type of particle. That could be one type of atom or one type of molecule. And we will look at some examples briefly. For a mixture, mixtures are substances that is a combination of two or more pure substances, meaning they are two or more different atoms or molecules mixed together. In most cases, they retain their original chemical and physical properties. So let's jump in and look at pure substances first, like we did in grade 9. Then we're going to go and look at mixtures like we did in grade 8. So a pure substance, again, contains only one type of particle. So there are two types of those. There are elements and there are compounds. Now, if we concentrate on the elements first, these are the items I want you to think of come from the periodic table. There are 118 elements that you can choose from. They contain one type of particle, either an atom, which means they are singular. So when I look at the periodic table, these are the ones that can occur by themselves as a single individual atom. So an example of this might be gold, solid. Gold is solid. It might also be something like aluminum is a solid. It might even be something like mercury, which is a liquid. They are singles, they are atoms, elements, one thing. Now, another pure substance, though, could be the same element, but some elements don't occur as atoms. They occur in groups of two or more. So, a molecule, we'll call them. Molecules are composed of one type of atom. Examples of this could be H2 gas. Hydrogen does not occur as an atom. It always occurs bonded to another hydrogen. So hydrogen, hydrogen bond together. The same type of atom we call a molecule, that would still be a pure substance. Another example might be Cl2 gas. Again, chlorine never occurs by itself. It always occurs in a group of two, so in a chlorine molecule. And another example of this might be phosphorus. P4 solid. Again, phosphorus never occurs by itself, but it's also not diatomic in a group of two. It always occurs in a group of four. These substances, these pure substances, these elements are substances that cannot be broken down further into any simpler units. Doesn't matter how much heat we use, how much electricity, an atom of gold is just that, an atom of gold. A molecule of hydrogen is just that, a molecule of hydrogen. We can't break it down any further. Now, that is different than if we come over here, and I need my tapping tool, to compounds. Compounds are still pure substances, but these pure substances are two or more kinds of atoms. So I'm going to have two different atoms or three off of the periodic table, and this is going to be, again, a repeating pattern. So it's a pure substance, one type of particle. So for instance, something that we might think about for this could be NaCl. Solid. This would be table salt or sodium chloride. In a container of salt, right, that you sprinkle in your corn on the cob, you're going to get a lot of these little crystals, a lot of NaCl's bonded together. And again, it's a repeating pattern. NaCl, NaCl, that's 100% only sodium chloride. Something different we might have that's maybe molecular, C6H12O6 solid. This would be glucose, a type of sugar. So again, it's the molecule makes up with 6 carbons, 12 hydrogens, 6 oxygens, and these atoms are bonded together to make this one molecule. Again, when I take a scoop of sugar for coffee, all the sugar looks exactly the same because it is one type of particle, C6H12O6. Another example that you might recognize would be H2O liquid. Now, you got to be careful on this one because if we're going to call it a compound, that means it's got to be 100% only H2O, nothing else inside of it. So this is distilled water because distilled water is 100% only H2O, H2O, H2O. You might also put over here something like candle wax, C25H52, which you saw from a previous video. These substances, when you heat them up, I can break them into elements. If I force electricity through H2O, I can break it into hydrogens and oxygens. If I force electricity through C6H12O6 glucose, I can break it into its carbons, its hydrogens, and its oxygens. Compounds can be broken down, but when they're a compound, like all pure substances, it contains only one type of particle. The particle is the glucose particle over and over. So glucose, glucose, glucose in a jar of, ideally, sugar. Hey, well, that was pure substances. Let's look at now what we did when we were in grade 8. And in grade 8, we looked at mixtures, combinations of 2 or more pure substances. So again, I'm going to need my pointer back here. And so there were 2 categories of mixtures. There was solutions that we also called homogeneous, and there was mechanical mixtures, which we also called heterogeneous mixtures. Now, we can use these words interchangeably. There is a nice way to remember them. Solutions and homogeneous are the same thing, just a different word. And we remember that because so-ho pairs together. Solution, homogeneous. So-ho means the same thing. Me, he means the same thing. Mechanical mixtures, heterogeneous mixtures, they mean the same. He, me, ho, so. So let's look at the definition of a solution. Again, we have 2 or more pure substances that we are mixing together. The thing about a solution is solutions, although we're mixing 2 or more things together, they're going to appear as one thing. They are going to look uniform and you're not going to see the pieces. So if I think of a substance that we mix multiple things together, but it appears as one is, when we make iced tea, you need iced tea crystals, you need water. When I mix it up and it all dissolves, it appears as one thing. Now, I'm talking about normal iced tea, not the iced tea that maybe some of you in Chem 20 make still, even though you're a little older, where you put way too many scoops of iced tea, and literally, when you take a drink, you have to chew the iced tea as you eat it because you like it so, so sweet. So I'm talking a normal person's iced tea where when you dissolve it, all the crystals dissolve and it looks like one substance. Another example might be flat soda pop. So you have a soda like Coca-Cola or Mr. Kemp's favorite orange soda. You pour it into a glass. The reason I say flat is I don't want you to go, ooh, look at the bubbles. There's no bubbles. There's no carbonation anymore. You can't see the soda and the carbon dioxide bubbles. This is going to look like one thing. When you're looking at a soda, you don't look at, let's say, orange soda and go, ooh, there's the aspartame. There's the glucose. There's the fructose. There's the corn syrup. There's the water. All those ingredients that you read on the back of the can, they all look like one item. That is the definition of a solution. Contains two or more pure substances, so we know it's a mix of something, but it appears as one. One more example I might squeeze on this is Jello. Jello. Now, this is normal people's Jello. This isn't grandma's Jello where grandma likes to put fruit in it. This is Jello powder and water that you let set, 1 cup of hot water, 1 cup of cold water, and it solidifies into one uniform piece. It looks like one full thing. All of it looks exactly the same. It's uniform throughout. That is a solution. Now, a mechanical mixture, on the other hand, is not uniform throughout. This is where we are going to, oh, Mr. Kemp clicked on something. This is where we are going to mix two or more things, and it's going to appear as two or more things, where it's going to have some parts to it. It's not going to look uniform. Perfect example of this is a chocolate chip cookie. And a chocolate chip cookie or a chocolate chip walnut cookie, you can point to the chips, you can point to the cookie, you can point to the walnuts, all those individual pieces. It does not look exactly the same everywhere. Other example of this might be Lucky Charms, the cereal. So you have the actual cereal, then you have the rainbows and the four-leaf clovers and the pots of gold. You got all those different marshmallows in there. So if you don't like the marshmallows, you can pick them out because you can see all the different parts. One of the most usual examples I like to use in Chem 20 is chili, because at this age, most people know what they like in chili. Maybe your family makes chili and you can see all the pieces. You can see the ground beef. You can see the onions. You can see the peppers. You can see the mushrooms. You can see the kidney beans. And if you don't like kidney beans, you love that this is a mechanical mixture because you can pick the kidney beans off and put them to the side. If you don't like mushrooms, you can pick them out and put them to the side. So mixtures, two types. Solutions are homogeneous. You mix two or more pure substances, but it looks like one. Mechanical mixture, a heterogeneous mixture. You mix two or more pure substances, but it looks different. You can pick out all the individual parts. So here is our all matter chart broken down, now combined together. We looked at the pure substances here where we have all the elements off the periodic table like gold and hydrogen. We also have compounds like distilled water or glucose. We then have mixtures where we're mixing two or more pure substances. If it appears as one, like Jello or iced tea, or you can see the pieces like Lucky Charms or chili. What I would like you to do is on this master sheet where you have the full table, can you please take these 9 examples and can you please pause the video, write them underneath the category they go. Are they an element? Are they a compound? Are they homogeneous? Are they heterogeneous? And think about where they would fit. Unpause the video to check over your work. So taking a look at this, tap water. Tap water is not the same as distilled water. Tap water has things dissolved in it. However, when you pour a glass of water, my guess is it all looks like one thing. So although it's got other things dissolved in it, because the wheat as a city takes out down to a level so tap water is safe to drink, but there's still dissolved particles and stuff in there. And some cities even might put in things like fluoride into their water. So this would go under the solution category or homogeneous. Carbon dioxide. Carbon dioxide is a gas, it's only CO2. CO2, 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 CO2. That means that this is a compound. Mercury comes straight off the periodic table, so that, of course, would be an element. River water, our third type of water, distilled water, compound, tap water, solution. River water, well, you look, there's water in that, there's fish, there's leaves. Sometimes, unfortunately, there's garbage. There's lots of things floating that you can see in the water. So I would call this a mechanical mixture or heterogeneous if it was me. Air. Air is made up of more than just oxygen, it's nitrogen, it's carbon dioxide because you breathe out, it's argon. There's lots of gases. But if you look, in most cases, I look around, air looks like one thing. So I would call this a solution or homogeneous because it's made up of many different gases, but it looks like one thing. Iron filings is just little tiny pieces of iron. Well, iron's on the periodic table, so I would call that an element. Baking soda, NaHCO3, is honestly a container filled with molecules of NaHCO3, NaHCO3. So this would be a compound group of two or more atoms, elements off the periodic table, repeating pattern. Cement, you have lots of different things in there. You have the cement, you have the little rocks and pebbles. You can see many different pieces. So I would call that a mechanical mixture or heterogeneous. And then copper 2 sulfate, it's not trying to be tricky at all. This is a solution. I threw it in because we used it in grade 9 and 10. So it's that beautiful blue liquid substance. But it actually comes to us as a solid. We dissolve it in water to make a solution. So it's kind of like the idea of Jello powder. You start with solid and you mix it into water, but it appears as one thing. So I would call this a solution, like it says, and that would be homogeneous. I hope this helps clear up all the concerns and helps you to understand again your all matter chart.